Hi, this is Poonam Fegre introducing NoSQL today. Today I'm going to cover relational databases, why NoSQL, what is NoSQL, CAP theorem, and difference between RDBMS and NoSQL. So first we start with the relational databases. Before NoSQL, relational database was the dominant database system which is used by all the enterprise which is used for all the enterprise applications. I have listed values of the relational databases which makes it dominant in 1990. So the first feature of the relational database was the tabular structure. Relational database supports table schema and allows the storage of structured data. So relational database supports the structural data. Another value is getting at persistent data. Persistent data is generally stored in a file system and database. For most enterprise applications, relational database was used as it is because it is more flexible than a file system for storing and retrieving data. Next property is that relational databases follows ACID rules. ACID rules means atomic. The relational database is atomic, consistent, isolated, and durable. The smallest execution unit in the relational database is the transaction, and relational database transaction follows ACID rules. That is, the transactions are atomic, consistent, isolated, and durable. Next feature is concurrency. Now, what is concurrency? Enterprise application can have lots of users working with the same data at once. Possibly they may try to modify that data. This simultaneous interaction must be coordinated to avoid for example, to avoid allocating same seats to two passengers in a railway reservation system. Relational databases helps to handle this by controlling all accesses to their data through transaction. The next important value of the relational database is integration. Um, Now, the enterprise applications requires multiple applications, and maybe different teams are working on these sub applications, and this sub application has to be collaborated in order to complete the task. Relational databases allow this using the shared database integration, where multiple applications store their data in a single database. So these are the values which makes the relational database dominant till 1990, and almost all the enterprise applications uses the relational database as their to fulfill their database need. Now we will move towards now why there is a need of NoSQL. So we have seen the features of the relational databases. Now we will see what are the drawback of the relational database which leads to the introduction of NoSQL databases. So as I say that relational databases continue to dominate the computing world till 2000. During 2000, there was a distinct shift to web services where applications would communicate over the HTTP. And this was the new techniques used for the communication. This was preferred at that time because it used more flexibility for the structure of the data. The data exchange is in the form of the XML, and recently it is used in a JSON format. So if you communicate with the SQL instead of XML or JSON, the data must be structured. For the SQL, the data must be structured, and this was not feasible for the high performance interaction. As the number of user increases, there was increase in the data, and the traffic on the network is also get increases. To cope up this uh, increase, the clusters of the systems were used. And the relational database are not designed to run on these clusters. So clusters are basically uh, the scale up of the systems is done, and for scaling up, the number of small systems are used with the commodity hardware, and cluster of such a small systems are taken because it is easy to increase, or it is easy to make a horizontal scale up of such a distributed system. And the relational database was not designed for such a distributed system. Nowadays, data have been increasing exponentially. The third party site like Google, Facebook has to deliver fast access to the data. For this, it is required to process huge amount of data, which SQL databases were never designed. The evaluation of the NoSQL is to handle this huge data properly. Okay. So, this was the reason. So we have seen the reasons why the NoSQL was introduced. Now let us see what is NoSQL. So NoSQL is commonly referred as a not only SQL. Means it is non-relational database. It is not a relational database. It is open source. Then it is it can store the unstructured data, and it supports the multiple processing nodes. Means it can be run on a distributed system. Generally for the distributed system it is introduced. It is schemaless. It don't have a fixed schema, unlike to the relational database system where the data is stored in a fixed schema, that is table schema. So here it is schemaless. It's avoid the join operation as it is schemaless, so there is no need of join operation. And it's easily scales horizontally, means new node can be added easily in an existing system, and the clusters of that systems can be formed, and NoSQL supports to scale that system horizontally. As we have seen that relational database system it follows the ACID rule. Likewise, here the NoSQL follows CAP theorem. So this CAP theorem is also called Brewer's theorem. So CAP theorems here there is it includes only three things: consistency, availability, and partition tolerance. And for studying the NoSQL databases or for implementing the distributed system, you must familiar with the CAP theorem. So first see what is consistency. Consistency means after performing the update operation, all users see the same data. And then availability means the system is also always available irrespective of failure of any node. And partition tolerance, systems remain functional on the system's split. Satisfying all these three at the same time is impossible theoretically. So when we think about consistency and availability together, so these are the actually characteristics of the RDBMS. So RDBMS doesn't support the partition tolerance. When you consider consistency and the partition tolerance, so these two features are supported by the uh, NoSQL databases like MongoDB, HBase, and Redis. Then the availability and partition tolerance, this supported by the NoSQL databases, for example, CouchDB, Cassandra, DynamoDB, and Riak. Now let us see what is the difference between RDBMS and NoSQL. So we have studied the RDBMS, and I have introduced you about the NoSQL features. So this is the difference, that RDBMS stores the structured and organized data, while NoSQL stores unstructured and unpredictable data. So unpredictable and structured data, for example, the data which is generated by the Facebook, then it is in the terms of the views in the comment, then uh, images, etc. By the structured data which is stored in RDBMS is in the form of tables in the rows and columns. Then RDBMS requires a structured query language to manipulate the data which is stored in any relational database system. Now it own supports any SQL language. It is not only SQL. Then data and its relationships are stored in a separate tables. Here there are various ways in which this NoSQL databases can store their data. It may be in the form of key value pair storage, or the column store, or document store, and graph in a form of graph. So according to these types, there are the various NoSQL databases: graph databases, column store databases, document, and key value pair database. Then in RDBMS, data manipulation language and data definition language is used, but here no declarative query language is supported for the NoSQL. RDBMS follows ACID rules, while NoSQL follows the CAP theorem. Then here tight consistency. In RDBMS, tight consistency is there, and here in a NoSQL there is a relaxation to the consistency, and priorities. It is generally used when priority is high performance and high availability and scalability. Means when the applications have the priority for the high performance, high availability, and scalability, then generally this NoSQL is used, and there is a relaxation. Means one relaxation is given for the consistency. So this is about the NoSQL. In my next video, we will come with the next topic. Thank you.